Hello, in this video, we will look at class abstraction and encapsulation. Class abstraction is the separation of class implementation from the use of a class. The details of implementation are encapsulated and hidden from the user. This is known as class encapsulation. Let's look at this diagram here. The class implementation is like a black box hidden from the clients. The clients use the class through the class contract. The class contract consisting the signatures of public constructors and functions. Class abstraction and encapsulation are two sides of the same coin. Many real-life examples illustrate the concept of class abstraction. Consider, for example, building a computer system. Your personal computer is made of many components, such as CPU, hard disk, memory, motherboard, fan, and so on. Each component can be viewed as an object that has properties and functions. To get the components to work together, all you need to know is how each component is used and how it interacts with the others. You don't need to know how it works internally. The internal implementation is hidden from the user. You can build a computer without knowing how a component is implemented. So let's look at the example of building the loan class. We already have this computing loan in chapter 2. Given the interest rate, number of years, and loan amount, we can compute the monthly payment and total payment. That program in chapter 2 is not reusable. So we put all things in the main function. Now, you can create some functions to get monthly payment and total payment, but it will not be integrated. So all this data, annual interest rate, number of years, and loan amount, they are not coupled. When you invoke the function, you have to pass all this data to the function. If we create a class, we can create objects from the class, and all this data now are coupled in the object. So what we do now is to have this class to have annual interest rate, number of years, and loan amount coupled in this loan object. We can invoke the get monthly payment to get the monthly payment from this loan object. So this is the UML diagram. We have this private data, annual interest rate, number of years, and loan amount. So those are the two constructors, loan. And so we have the get functions and set functions, and get monthly payment and get total payment. So now this is the header file for the loan class, and this is public, the constructors, functions, get functions, set functions, and get monthly payment, get total payment, and these are the private data fields. Now, we're going to write a test program before we implement it. So this is the test program. Prompt the user to enter the annual interest rate and the number of years and the loan amount. And now you can create a loan object using annual interest rate number of years and the loan amount. Once you have this object, you can get its monthly payment by invoking the get monthly payment function. And this is to get the total payment, loan.get total payment. So this really helps to understand the loan before you implement it. This is what happens in the real world. You develop your class for the other people to use. And so now in this class, we will play the role as the user and also as the implementer. So we are the developer to implement the class now. So let's implement the class. This is the class, the loan class, loan.cpp. It's the implementation of the header file. So this is the NOAA constructor. So this is another constructor here. So here is, this is the, we're gonna have this years is, this is the, so this is the annual interest rate, and this is the data field is number of years, and that is years. And this is the annual interest rate. So we're going to read annual interest rate. And this is get years. So this is get. Now, so you have class before the functions. And this is get loan amount, the set annual, set number of years, set loan amount, and this is the monthly payment. Total payment is monthly times 12 and times number . So in this example, we give the UML diagram for the loan class. Students should be by writing a test program that uses the loan class, even though they don't know how the loan class is implemented. This has three benefits. First, demonstrates that developing a class using a class separate tasks. Second, it enables you to version of certain classes without interrupting the sequence of the book. Third, it's easier to learn how to implement a class if you are familiar with the class through using it. For all the examples from now on, you may first create an object from the class and try to use its functions before turning your attention to its implementation. That is all for this section on class abstraction and encapsulation. See you on the next